This is part 3 of our video on exponent laws. In this part, we're going to go through some practice questions of how to apply the laws that we've learned in the other parts. So we're going to start by simplifying each of the following as fully as possible. So when I simplify, it means I want to try to combine them all down to one power at the end so that I only have a single term if that's possible. So the first question here, we have x to the power of 3 times x to the power of 5 divided by x to the power of 4. So I'm going to multiply the two powers in the numerator first, and then we'll do the division second. Now the rule that we talked about on the previous video is that when you multiply two things together that have the same base, you add the exponents. So here, x to the 3 times x to the 5, you add 3 plus 5 to get x to the power of 8. And then I leave the x to the power of 4 in the denominator. And on the next step, I'm actually going to do the division. So x to the 8 divided by x to the 4. The rule we learned for that is that if the bases are the same, which they are, we subtract the exponents. So 8 take away 4 is going to give me 4. So my final answer here will be x to the power of 4. The next example is a little bit more complicated. This one has multiplication. It has a bracket in the base, in the bottom it has a bracket as well, and then there's some division going on. When you have a question that has multiple operations, you do want to follow your order of operations or your bedmass rules. So you want to start by looking at any of brackets you might have. So I do have a bracket in the numerator that has some multiplication in it. And I have a bracket in the denominator that really doesn't have anything to do in it. So I am going to start by doing the bracket with the multiplication here. So x to the 2 times x to the 3. We add when we multiply, so that's going to give me x to the 2 plus 3, which is 5. And that is still in brackets to the power of 5. In the denominator, that x to the power of 4, there is nothing to do inside that bracket. So I'm just going to recopy down x to the 4. To the power of 3. So we've taken care of our bracket. Then I do any exponents. And I know there's lots of exponents here. We have exponents on all of our bases, but really we're talking about an exponent outside of a bracket. So we're talking about the 5 and that 3. So what I'm going to do is evaluate my nested exponents next. So the rule we learned was that when you have a power on top of a power or a power outside of a bracket, you multiply. So 5 times 5 is 25, so x to the 25. And in the denominator, 4 times 3 is 12, so that's x to the power of 12. And then our final step, we divide. And in our rule for division, if the bases are the same, which they are, you leave the base alone and you subtract the exponents. So 25 take away 12 is 13. Now these next set of questions are a little bit more complicated because they have coefficients in front. So we've got multiplication, so 3x to the 7 times 4x to the 4. And then in the denominator we have 6x cubed. So I'm going to start in the numerator and I am going to multiply. I do have brackets here, but there isn't anything to do inside of the bracket. That's just ways of separating our two terms and showing that we're going to multiply them. I'm going to start with the x's, so x to the 7 times x to the 4. We know the rule for that is that you add your exponents. So copy the base, which is x, and then add 7 plus 4, which is 11. But the coefficients are the new part here. So these are not the same base. So I cannot use an exponent law with the 3 and the 4 since they are not the same base. What I am going to do is just simply multiply them together. So 3 times 4 is 12. And in the denominator, I still have 6x cubed. On our next step, we are going to divide. So start with the exponents. X to the 11 divided by x to the 3. The rule for this is subtraction. So 11 take away 3 is 8. And then 12 and 6 are not the same base. So I cannot use exponent laws with those. I'm just going to simply divide 12 divided by 6, which is 2. So my answer here is 2 times x to the power of 8. All right, the next one here is a little bit more complicated, but it's just extra practice of what we just talked about. I have 5x to the 10 times 8x to the 6 divided by 2x to the 3 times x to the power of 4. So I'm going to do the multiplication in the numerator and the multiplication in the denominator first, and then I will divide my two answers. So I will start with the exponents. X to the 10 times x to the 6. The rule for that is that you copy the base and you add the exponents. So 10 plus 6 is 16. And then the 5 and the 8 are not the same base. So I cannot use exponent laws here. So I just simply do 5 times 8, which is 40. In the denominator, I have x to the 3 times x to the 4. So we add, leave the base the same, and 3 plus 4 is 7. This is a 2. This one here does not have a coefficient, which means it must be a secret hiding 1 there. So since these are not the same base, I just multiply. 2 times 1 is 2. And then to do the division, x to the 16 divided by x to the 7, I subtract. So 16 take away 7 leaves me with x to the power of 9. 40 and 2 are not the same base, so we just divide the coefficients. 40 divided by 2 is 20. If I take a look at the next two all have to do with the power of 0. So this one here, we have 3x to the power of 0. And we learned the rule for the power of 0 is that anything to the power of 0 is 1. So here I have 3x in a bracket, all to the power of 0. Since this whole thing is to the power of 0, this just equals 1. Now the next one is a little bit different. You'll notice this one does not have a bracket. It is 3x to the power of 0. This is not the same thing as this. This is actually the same as 3 times x to the power of 0. The way an exponent works is the exponent works on whatever is directly to the left of it. So what's directly to the left of this 0 is an x. So the x is the only thing that that 0 is going to work on. What's directly to the left of this 0 is a bracket. So everything inside that bracket is going to be to the power of 0. That's what the 0 is working on. So here, since it's just on the x, I still have that 3, and then x to the power of 0 is 1. And 3 times 1 is 3. So you do have to be careful and watch, pay attention. Is there a bracket? Is there not a bracket? Right? What does that mean? All right, the next two, we have powers on powers, but we also have coefficients. So for this one, I'm actually going to write it out 3 times, see what I get, and then we'll look at how to do it with the exponent law. So 2x to the power of 5 would be 2x to the 5 times 2x to the 5 times 2x to the 5 3 times because it's to the power of 3. And if I multiply, if I do the x's first, x to the 5 times x to the 5 times x to the 5, the rule for that is adding. So 5 plus 5 plus 5 is 15. And then 2, 2, and 2 are the same, so I could use exponent laws on those, but they really are just coefficients, and I can multiply them together. So 2 times 2 is 4, times 2 is 8. So this should come out to equal 8x to the power of 15. Now there is a way to do that with exponent laws. So if I take a look here, we said the rule with a nested exponent or an exponent with a bracket is that we multiply it in. So I would do 3 times 5 to give me my x to the 15. But the 2 actually has an exponent. Anything that does not have an exponent that you can see always has an exponent of 1. So when we multiply the 3 in, we actually multiply it into each term in our question. So I'm going to do 3 times 5, but I'm also going to do 3 times that exponent of 1. So that would give me 2 to the power of 1 times 3 is 3, and x to the power of 5 times 3 is 15. And 2 to the power of 3, if I work it out on my calculator, gives me 8 x to the 15. So the same answer. So when you have a bracket and you have more than one thing inside, you need to make sure that you multiply the outside exponent into all of the exponents on the inside. So let's try another one just to make sure that we understand what we're doing. So 4x to the 9 to the 5. we're going to multiply 5 times 9, but we're also going to multiply 5 times that invisible exponent of 1. So this is going to give me 4 to the power of 1 times 5, which is 5, and then x to the power of 9 times 5, which is 45. 4 to the power of 5 is, well, I don't know off the top of my head. Let's take a look. I'm going to use my calculator. 4 to the power of 5 is 1024. And then I don't have a way to evaluate x to the 45, so it's just x to the 45. All right, the last two examples have multiple steps to them. So we're going to start with 5x cubed squared times 2x squared to the 5, and then divided by 10x to the 4 to the 3. So the first thing I'm going to do is put in all those invisible exponents of 1, because I see that I have exponents on the outsides of all of those brackets. And I am going to follow my BEDMAS rules. So I am going to start with brackets. There really isn't anything to do inside of any one of those brackets. Next up, exponents. That's the 2 on the outside of this bracket, the 5 on the outside of this bracket, and the 3 on the outside of that bracket. I'm going to multiply those in to each of those brackets. So that's going to give me 5 to the 1 times 2, so 5 to the 2, x to the 3 times 2, so x to the 6, and then 2 to the 1 times 5, which is 5, and x to the 2 times 5, which is 10. 10 to the 1 times 3 is 3, and x to the 4 times 3 is 12. Now before I do any other exponent laws, I am going to simplify 5 to the 12, 2 to the 5, and 10 to the 3. 5 to the 2 is 25, x to the 6. 2 to the power of 5 is 32, x to the 10. And 10 to the 3, there's a nice little shortcut for multiplying out tens. You take the exponent number, and that's the number of zeros you need to add to the end. All right, so the next step, we are going to multiply. So I'm going to do the exponents first. X to the 6 times x to the 10. The rule is that we add. So I get x to the 16. And then 25 times 32, I need my calculator for that. So 25 times 32 is 800. Divided by 1,000, x to the power of 12. And then to do the division, I'm going to do the exponents first. We subtract. That's the rule for division. So x to the 16 divided by x to the 12. I do 16, take away 12 is 4. Now 800 divided by 1,000 does not work out nicely. 800 divided by 1,000 is going to give me a decimal of 0.8. I do not want a decimal here. So what I'm going to do instead is I'm going to just reduce the fraction as much as I can. The first thing I notice is that they are both divisible by 100, so I can divide the top and the bottom by 100, which would give me 8 over 10. But 8 over 10 does reduce a little bit further. I can divide the top and the bottom by 2. 8 divided by 2 is 4, and 10 divided by 2 is 5, so I get 4 over 5 times x to the power of 4. So sometimes you will get a fraction, and that's okay. We're going to have to save the last question for the last part because we're running out of time.